Hey, Mr. Midas is here. It is 8 o'clock, and I am going to be talking about the pre-calculus study guide tonight and going through the study guide item by item, so that way you can take a look and see if you got things right or wrong, and answer some questions in the group chat. So just go ahead and chat. I don't see any viewers right now, so I'm probably going to hang out just a few minutes here and wait for somebody to get online here, and then as soon as I get a couple of a viewer or two, then I'll go ahead and get started. Okay. So right now you'll just kind of see a bunch of nothing going on until I can get everything set up. So I'm probably going to hang out. All right, let me grab this and get this ready here. I see there's 7 viewers. If you can you try the chat feature to make sure that I'm getting the chat? I had last time I did this, I had some trouble looking and see if there was chat or anybody was asking any questions. I had to go through like different screens. So if you can see and check that for me, just say hi or whatever, and then I'll know that you're online there. Yeah, so for some reason the chat feature on my side right here doesn't work, but I can keep going and looking at in my control room to, oh look, there's a control room. Let's see if I can. Okay, well, I'm gonna have to keep going back and forth from the chat area. So if it seems like I kind of cut out for a second, it's because I'm going to look and see if you have any questions. So, every once in a while I'll go and check, but I won't guarantee that I can answer questions as they flow through, just because it doesn't show up on my screen very good here. But I'll do the best I can. All right. Right now I've got, let's see, we got Brandon Lee, Anthony, Tyler, Missy. Those are the names that I got, at least on the side here. So welcome. And let me check again. Okay. All right. So let me go ahead and go through this. Hopefully you have the review problems. If you don't, I'm going to show them up here, and I'm going to go ahead and show you my iPad as I'm going through this, so you'll be able to see that. All right, so here is Hopefully you can see that. You should be seeing my my pre-calculus. And yes, you can use Classroom as well to ask any questions. I'll have my Classroom up on a different screen here, and then I'll answer some questions that way too. So either through the YouTube screen or Classroom will work as well. Okay, so let me go and get started. We'll look at number 1 here, and I'll go through all of these. I'm going to try to go as quick as I can, but still be thorough. So, you know, as to not, you know, take forever, but still be understandable. Okay, so here we go. Number 1. If you can't see this and it's not big enough on your screen, let me know and I'll see if I can zoom in here. But for now, this is pretty much as big as I can get it. Otherwise, it kind of tilts it in a weird way. So we've got f of x equals x squared minus 4, g of x equals 3 square root of x plus 4, and we want to find f of g of x. So we're looking for the composite. So how do we find the composite function? Well, we're going to take g of x, and we're going to plug it in here for x. Okay, because this is f of g of x. So we're going to take g of x, plug it in here for x. So we're going to get 3 root x plus 4 squared. Now when we square that, we've got to square the 3 and the x plus 4. So we're going to get 6. What am I talking about? 3 squared is not 6. That is 9 times the square root squared. So the square root squared just drops out, and we have x plus 4. If my stylus wants to write here. Stylus, okay. Quick pause. Let me get a new stylus and see if that's the problem. I cleaned the screen the other day. Let's try this one. There we go. That one works better. Okay, so hello, Vinay, Brianna, Tyler, Camry. Looks like I'm starting to get more people here. So then we get, we're going to go and multiply that through. So we're going to get 9x plus 32, and that's going to give us our answer of C. Okay, so let's do number 2. Which of the following functions is neither odd nor even? All right, so here you can see that we have cubed, and that's to the 1 power. So that's going to be odd. So the first one here is odd. We've got all even powers in a polynomial. That's going to tell us that that's even. This one here, we're going to have an even, and this absolute value actually is neither. So I guess we got really 2 answers for this. So I really want to have this as absolute value of x minus 2 with the minus 2 outside. You know, otherwise this is going to shift the x minus 2. It's going to shift that's going to shift the absolute value function to the what's this, minus 2 if it was inside. So it's going to shift it to the right 2 units, which is going to give us neither odd nor even. So I really need to change this to absolute value of x minus 2. Otherwise, it's going to be an even on top, and a neither on bottom is going to be neither. So given that this is absolute value of x minus 2, this is going to be an even over an even, which gives us an even function. So we have an even here, an odd here, that's neither. Okay, so which is the right answer? Neither is D. Okay, any questions? Hello, everybody. Greetings, greetings. Nice to have you today. We have 12 viewers in this live stream right now, which is pretty good. We'll go ahead and keep going here. So which of the 12 basic functions? It's going to be very important that you know the 12 basic functions and really the properties that each of them has. So really all you got to do is know what the graph looks like. ln of x looks like that. Greatest integer function looks like that. E to the x and 1 over x. So which one of these is odd? Well, 1 over x is odd because it is symmetric about the origin. All right, let's move on to number 4. After the first 5, then I'll pause for any questions that you have on each of those 5s. Which of the 12 basic functions has 2 horizontal asymptotes? Well, it's not often that things have 2 horizontal asymptotes. This one we just drew right here. That one clearly doesn't have any horizontal asymptotes. E to the x has 1 asymptote right here, 1 horizontal. Y equals 1 over x has 1 horizontal right there. And this is the logistic function. And yes, I know I should have put a little negative in there, but it's, it's still going to be logistic. And if you remember, logistic looks like this. It has a horizontal asymptote here at 1 and 1 here at 0. So B is the answer for which of the 12 basic functions has 2 horizontal asymptotes. Okay, 5 is probably the one that was a little bit tricky. So I'm going to need a little bit more room than I have here. So I'm going to go ahead and open up a new page. Let's see. So I can open up a new page. Okay. Let's see what my problem was. F of x equals 4 over x minus 1, and g of x equals 2x. Okay, so f of x was equal to 4 over 2x minus 1, and g of x equals 2x. Now, I think that's wrong. I think that should be x minus 1. I'm going to go take a look here. X minus 1. Yeah. Okay, I was getting a little ahead of myself. Okay, 4 over x minus 1, g of x is 2 of x. And what I need to do first is I need to take f of g of x. So f of g of x, I'm going to take 2x, and I'm going to plug it in here for x. So I'm going to have 4 over 2x minus 1. And g of f of x is, I'm going to take this, and I'm going to plug that in here for x. Okay, let's go to a different color now. So now we're going to take these two and set them equal to each other. So 4 over 2x minus 1 equals 8 over x minus 1. Now, when we ever have a fraction right here multiplied by a whole number, we're just going to multiply the top. We're going to leave the bottom the same. Then here, I'm going to cross multiply. Okay, like a little heart. So I'm going to have 4 times x minus 1 equals 8 times 2x minus 1. Yeah. What is going on with my iPad? 4x minus 4 equals 16x minus 8. Excuse my writing. My handwriting is just not as great. Subtract 4x, add 8. So we get 4 equals 12x. Divide by 12, x equals, looks like 1/3. Let's go see if there's an answer. Well, 1/3. There is. It is A. Woo! Got it right. All right, let me pause for a second if there are any questions. All right. So did that work? Was everybody able to see the work done? For some reason it said presenting, and then it said present, like it said screen sharing. So I wasn't sure if it was presenting or not. So hopefully it worked. So if it did, you can give me a little emoji, thumbs up, smile face, whatever, and then I'll move on to the next part. Again, I'm trying not to take up too much of your time tonight. Let's see what we got here. Oh. Is logistic the only parent function with two horizontal asymptotes? Yes, it is. Logistic is the only parent function with two horizontal asymptotes. So even though like cosine and sine are bounded between 1 and -1, like they keep going up and down, up and down, up and down, but they don't ever get higher or lower than 1 and -1, those are not considered asymptotes, because they don't approach those numbers as we go out to infinity or negative infinity. They just keep bouncing in between. So those are not considered asymptotes. And then the only other one I can think of that even would come close is greatest integer, but again, that just keeps on going forever and ever. So that one doesn't have a horizontal asymptote as well. So I cross multiply because in order to solve a proportion problem, when you have like a fraction equal to a fraction, in order to solve it, you cross multiply. That's kind of the method. So we're going to just take the denominator, multiply, okay? And that's why we cross multiply. Well, that's just the way we have to solve it. There's no other way to do it. Oops. Okay, so I'll go ahead and move on now. Answer some of those questions. How did you get the 8 over x minus 1? I got 8 over x minus 1. Let me share this back with you here. Let's see, where am I? Here we go. So let me go back to my work here. The 8 came from the 2 over 1 times 4 over x minus 1. So right here. I only multiply the 2 times the 4, that gives me 8, and then the x minus 1 in the denominator just stays the same. Okay. All right, let's go and move on to the other ones. Hopefully answer those questions. Which of the following is symmetric about the origin? Well, you're kind of looking at it going, well, do I have to graph all of these? That's going to really kind of suck if I have to graph all of them. That's going to take a long time. Well, that question there isn't meant really for you to graph anything. I'm drinking some water. This question is for you to understand that when something is symmetric about the origin, it is an odd function. So really what you're looking for is which one of these functions is an odd function. All right, this is not an odd function, because if you plug in negative x, okay, you're not going to get, negative x minus 1 over negative x, right? It's not, it's just not going to work out. So that one doesn't work. Just at a quick glance, we can see that this power is odd. Let's zoom in here. This power is odd, and this power is odd. It's power of 1. So since both of these powers are odd, this is our odd function, which is symmetric about the origin. Okay, so it's very important that you understand that symmetry about the origin means odd function. All right, so let's look at these graphs here. There's some questions about these graphs. I've got all these things going on here. For this problem here, notice if you I'll zoom in real close on D here. You notice here that D does not cross through the origin, but A does cross through the origin. Okay, so that's going to be really important when we look at the next problem here. So which of these graphs is an odd function? So just like I said, since this D right here, since D does not cross through the origin, this one does. And clearly this is not, well, this kind of weird right here, right? This one is even. This is even because it is symmetric about the y-axis. This is odd because it's symmetric about the origin. This one right here. So the answer for 7 is A. Well, I just answered 8. That was B, right? Okay, so done. 7 and 8. Woo, that was easy. All right, so with this one here, this is decomposing functions. I know you're probably going, God, Mr. Meneses, you made it so tricky. All of them are cosine 1 over x and ln of x. Which one's going to be the right answer? They're all like, which one's the right one if they're all the same thing? Well, they're not all the same thing. The order is important. So remember that you're putting h of x into g, and whatever you get there, you're putting it into f. So f has to be the outside function, which looks like it's going to be ln. Then g looks like it's going to be the first inside function, which is going to be 1 over x. And then h has to be the most inside function, cosine x. You can also think about it if you were going to graph this step by step, you would go inside out, right? Inside out would be cosine, then 1 over x, then ln. So h has to be cosine, right here. H is cosine. Then g is 1 over x, then f is ln of x. So the answer is B. Okay, number 10. This one's a tricky one here. Find the domain of square root of x over square root of 1 minus x. Now, I don't think that there's one this hard on the exam. And I think the reason this is hard is because we have to deal with this inequality that's a square. And I really didn't really teach you how to do square inequalities. This is one that I kind of assume that you learn in Algebra 2, which nobody really learned this in Algebra 2. And I think I covered it with a few students, but not everyone. So I don't think I'm going to go with a square, a quadratic here in a square root. I might save that till next unit or the unit after that. But in any case, let's go ahead and solve that. We know that the top here is under a square root, so x has to be greater than or equal to 0. Down here, 1 minus x squared is going to be greater than 0. Now, why is it just greater than 0? It's greater than 0 because we're in a square root, so that's greater than or equal to, but it's in the denominator, and it can't be 0 in the denominator, so I'm just going to put greater than. It cannot be greater than or equal to because it can't be equal to it. So how do we solve this? Well, first we're going to solve it for x, and we're going to get plus or minus 1, right? Because we're going to add 1 over, or we can add x squared over, then take the square root. And then we're going to use a number line, -1, and 1. And we've got open circles here. And we're going to test 0. And we're going to test 0 right in here just to see what it does. So when we put 0 in here, we're going to get 1 minus 0, which is 1. Is 1 greater than 0? Sure it is. So that means that all of the values in between -1 and 1 work. So since all the values between -1 and 1 work, but this one tells me that it must be greater than 0, we got to put these together. And that means that it's going to be from 0 to 1. And that's my domain. So you see, oops. Sorry, this was a parentheses. Yeah, I noticed that I made an error because right there was the answer, but it didn't have brackets out of parentheses. And it's parentheses because it's greater than. It's greater than right here, not greater than or equal to. Okay, let me pause for any questions that you might have. That guy with a face. That's an interesting name. You have a nice house. Yeah, I don't know how much of it you can see. You pretty much only see my fireplace. It's dark. I have to close up the rooms here because my kids just went to bed. Can you go over 6 again, please? All right, let's see where 6 was here. All right, so let me talk about 6 again. I'll talk about each one of these. First, I'll say again, symmetric about the origin means that the function is odd. So that's really what it boils down to here. You got to know that symmetric about the origin means odd. So you can either determine if it's odd by plugging in the negative x, or you can just kind of you can graph them all. So what I did was I went through each of these. I went through the first one. Okay, I went through that one, and this was neither, because it didn't work out when I plugged in the x. So this was neither. This second one here, if I plugged in negative x, okay. Well, I can even graph this. This is a cubic shifted over to the right 1 and then down 1, right? So it looks like that. Well, that's neither. And then D, well, D is even. That's a square there. So this is even. So what's the only function here that's odd? C. C is the odd function because it has 2 odd powers, 5 and 1. Okay? Now, again with number 9, you got to go inside out. You're thinking, okay, which one of these, if I put H into G and whatever I get there into F, will give me this thing here? Okay, well, it's got to be this one here. Because look, if I put this, and that's because this is the directions. Okay, F of G of H. So H has got to go into G, and then wherever you get there needs to go into F. All right, so you go back over here. Look at this. All right. H goes into G. So G of H of X, oops, is equal to 1 over cosine X. Because I put this cosine into here. And then when I put this into F, it's going to be ln of 1 over cosine X, which is what we had over here. Okay? So that's why it has to be B and it can't be the... You know what? If you get to this problem and you can just check each one of them, put this into that, 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 and see which one lands on the right answer. Yes, Jake, that's correct. Inside out. Inside out. You got to remember it goes inside out. Thank you, Brianna. Yes, we're basically decomposing. This is a decomposing problem. We're decomposing the function. So remember that okay, so when I plug in 0, when you plug in 1, you get 0. Right, we do get 0. That's what we solved right here. If I plug in 1, if I plug in this 1, into here, I'm going to get 0 greater than 0. That doesn't make any sense. That's why I have an open circle here. Okay, so I want to test a point either inside or outside. I could have tested 2 or -2 also. And if I tested 2, I'm going to get 1 minus 4. That's -3. -3 is not greater than 0. So this whole part right here would have been false. Same thing here. This would have been false. The only thing that works is the inside between -1 and 1. That's why it's got to be in here. Okay? Yeah, it is an open circle because it's greater than. Okay, so I'm going to move on to 11. 11 is not that bad. Look, if you just really have to know your translations, right? This inside is going to move to the right 2 units. And this is going to move up 1. So what I'm going to do with this cubic is I'm going to take the center part and I'm going to move it 2 units there and up 1 unit there. And then I'm going to get this curve there. So let's see if I can find that one. Over 2 and up 1. Okay. This one goes over 1 and up 2, so it can't be that one. This one goes over 2 and up 1. And that's the right one. Boom. B. Okay. All right. 12. The horizontal asymptote of 4x squared minus 9. And then this should be one of the easiest ones on the test, okay? Because all you got to do is look at you're looking at the powers. Ooh, that's a thick writing there. Let's see if I can thin that up a little bit. Okay, so you're looking at the powers right here, 2 and 2. If the highest power of the numerator is equal to the highest power of the denominator, then you're going to take the numbers in the front. So 4 over 1. 4 over 1 is your horizontal asymptote y equals 4. So it's B. Okay. Now 13 through 16, I feel like these are the easiest. I made a typo error on number 16. It shouldn't be G inverse of 1. It should be G inverse of -1. And I think in class, I said that D should have been +2 instead of -2. You know, either way, those typos would have worked. I'm going to go and use G inverse of -1 because it's different than what I went over with some students in class. So first we have to find f of 2. So f of 2, we're going to look on the table. We're going to go to x equals 2, and we're going to go to f. There it is, -2. So -2 times -2 is +4. Boom. What do you do if there are 2 exponents on the top and the bottom of the fraction? You take the highest one for each one. So I think your question is, what if it looks like this? I think that's your question. If that's your question, now notice that I kind of rearranged them all too. So you take the highest one right there, x to the 4th. X to the 4th, they match up. So your answer is y equals 2/3. Okay? Okay, back down here. I have a question. Can we get a tour of your house? It's too messy to get a tour of my house. 10 will always be greater than. Well, in number 10, Brandon, number 10, it says it's greater than because it's in a square root. So yes, when things are in a square root, it's always going to be greater than or equal to 0 because it's underneath a square root. In this case, it's greater than because it's in the denominator, and in the denominator, we can't have anything equal to 0. So that's why here I have it greater than 0. You know, just like, you know, another example would be something like 1 over x minus 2, right? X minus 2 cannot equal to 0 for this domain. If I had square root of x minus 2, then I would, and I have no, you know, no fraction, then that would be x minus 2 is greater than 0, greater than or equal to 0, just like I did with the top there. So whatever's in the whatever is in a square root needs to be greater than or equal to 0. Whatever's in the denominator needs to be not equal to 0. Okay, where are we? All right, here we go. So we're back here. I think I had a question from Jake, or did I answer your question? So only divide with the largest exponent. Yes, only divide with the largest exponent. And if the largest exponent in the bottom is higher than the largest exponent in the top, then you got y equals 0 as your horizontal asymptote. You know, I think these are fairly easy. I'll just go through these real quickly. G of 0 is 3. F of 2 is -2. We just did that. G of 0 is 3, so we're going to get 4 plus, oops, what you talking about? Willis is getting late here. 2 plus 9, which is 11. Okay, F of G of -1, so G of -1 first is 0, and F of 0 is 4. Okay, so we got B. G inverse of -1, instead of looking at, instead of going over here and finding -1 in the x and going down to G, we're going to go opposite. So that's not the way we're going to do it. We're going to go look in the G for -1, and then we're going to go up to the x, and there's the x. So this is our answer. So the answer is -2. Okay, so those were the only multiple choice that I put on the study guide. There will be 20 multiple choice tomorrow on the test. So expect 4 more that you might not see in here that will be on the test. Okay? Okay. So now let's take a look at the free response problems. These are pretty similar to what's going to be on the test. I'm not gone. I'm just pausing for a second. Okay, so let me get going here with the next ones. So I have this function here, and I want to, excuse me, I want to translate this function, 3f of -x minus 1. So the first thing, I'm going to go inside out with these as well. So the first thing I'm going to do is start with my negative in my parentheses. All right, so is period 6 getting blocked for some reason? Yeah, let me try. I'm going to put another give me 1 second here, folks. I'm going to try to So the first thing I'm going to do is start with my negative in my parentheses. Well, that was weird. I heard myself twice. Okay. All right, so what I'm doing here is I'm putting up a different link. And you can check to see if this link works better. Okay, so here's for period 6. I'm not sure why it's not working for period 6 for some people. All right, so Isai, Asia, and I don't know if you can hear me, but if you guys know Isai, Asia, and oh, duh, I could just type it in Classroom. Okay. Restricted on your Chromebook. Oh. Okay, so it looks like it's not working on Chromebooks for some reason. I don't know how to fix that. Sorry about this, guys. I'm just having some errors here. Yeah, it says don't use a Chromebook. So if you can do this on something other than a Chromebook, I'll try to see why it's not working on a Chromebook, and you know, hopefully it works out better. Thanks, guys, for listening. Okay, so I got to get going here. I got to keep going here because otherwise we're going to be here, for over an hour, and I don't want to do that. So number 17, we're going to start with the negative x here. So we're going to start with the negative x, and remember that the negative x reflects. Whoa, that's a big X. S about the y-axis. Okay, so I'm basically gonna multiply these x values by a negative. All right, so my first step is going to be in purple. Thin this out a little bit. F of negative x, okay, is purple. So instead of being here at positive 2, I'm going to go to negative 2. So that point's going to be there. Instead of being at positive 4, I'm going to go at negative 4. Okay, so there's the point there. Connect those. Okay, this is still going to be at 0. Instead of being at 1, 2, 3, 4, 5, 6, I'm going to be at negative 6. So 1, 2, 3, 4, 5, 6. Then on this side, negative 2 is now going to be a positive 2. And negative 4 is going to be a positive 4. Okay, so there's my first move, f of negative x. Then I'm going to multiply by 3. And multiplying by 3 is going to take my y values and multiply by 3, but leave my x values alone. Okay, so I'm going to take my y values. I'm going to have 2 here. So I'm going to multiply that by 3, which is going to give me 6. So 1, 2, 3, 4, 5, 6. And there's my new point. All right, same thing here. My x value here is just going to stay there. It should stretch it out. That's what it looks like it's doing. Okay, 0 here. This one's going to be down -6. 1, 2, 3, 4, 5, 6. And down to -6. Okay, so this goes all the way down there and all the way over there. Okay. So it stretched it out. Whoop. That's my sound effect for stretching. Whoop. Now I'm going to subtract 1. So subtracting 1, let's go with blue. Subtracting 1 moves everything down 1 unit. All right, so I'm going to move everything down 1 unit. So down 1 unit. Right there. Right there. Right here. 1, 1. Oops. And this one's going to be 1 right there. So up, over, through this one, and across. And there we go. That's going to be my answer. All right. So just take them step by step again. And colors are nice because it's easier to follow when you're using colors like I did here. So if you have some colored pencils, you can use some colored pencils. Okay. You can watch it on the school account, but guest and other accounts should work. Huh. Good to know, Jake. So the multiple choice, I can't say is going to be exactly like what's on the test. I can say it's going to be similar. So, you know, I would say close to, but not exact. You know, it's kind of hard to make multiple choices. So I'm not just going to change the words and change the numbers on the multiple choice. I want them to be the same type of questions, but different. Thanks for the tip, Jake. I will tell them to do that and see if that works. Okay. So let's move on to the rest of them here. This is the big guy. This is the one that's worth the most amount here. So, you know, we'll be real quick on this one too, though, because this one's not as hard to graph. 1 over x minus 3 squared. So the first thing is you can find the vertical asymptote, right? The vertical asymptote, we're going to take the bottom, we're going to take the denominator, set it equal to 0. And we only have one asymptote, so x equals 3. So I'm just going to go ahead and right now and write x equals 3. I also know that the horizontal asymptote is y equals 0 because the top is smaller power than the bottom. This is a power of x squared, and the top is 1. So I'm going to go over here, and I'm going to graph that. Okay, so I got my vertical asymptote at 3. Make this a little thicker here. Vertical asymptote at 3. And it's squared, so we're going to have a positive, 2 positives going like that. And the reason I know it's going to be that is because it's 1 over x minus 3 squared. And 1 over x minus 3 is the reciprocal function just shifted over 3 units to the right. And then when I square a function, everything's going to be positive. So it's got to be both up on the top of the y-axis, or I'm sorry, the top of the x-axis. All right, so let's take a look at the domain and range and stuff like that. So the domain here is going to be negative infinity. I'm going to need to zoom in here, but it's negative infinity to 3, and then 3 to infinity, because it's all the stuff that's happening here on the x-axis, where the range is the y-axis. So the range is going to be It looks like it's only going to be from 0 up to infinity for the range. Okay, so we're going to go ahead and write those in. Oops. So the domain is going to be negative infinity to 3, then 3 to infinity, and the range is 0 to infinity. All right, are there any extrema? Well, I don't see any max or mins in this graph. It doesn't have any peaks, so we're going to go and say none. Where is it increasing? Well, it looks to me like it's going to increase here, okay, because it's going positive slope, and decrease here, because that's negative slope. So, positive slope from negative infinity to 3, negative slope from 3 to infinity. Now let's see if it's concave up. It looks concave up to me right here. This is concave up. All right, concave up, concave down. Right? Concave up, concave. Actually, these are both concave up. Concave up, concave up. It doesn't, we don't see any scooping downwards. That's concave down. So I don't see any scooping downward. This is both scooping up. So we're not going to have any concave down. So concave down, we're going to put none. And concave up, we're going to go negative infinity to 3, and then 3 to infinity. All right, now we're looking at the end behavior. Remember that the end behavior is anything that goes out to infinity. So what's happening to the graph? What happens to the y values as x gets smaller? So as x gets out there and as x goes out there. Well, it looks to me like y is going to approach 0. And as x goes out to infinity this way, y is going to approach 0. So these are both going to be 0. You can also think of the end behavior as the horizontal asymptotes. So you're normally going to have the horizontal asymptote as being your end behavior, but if you don't have a horizontal asymptote, then it's going to be negative infinity or positive infinity, depending if your errors go up or they go down. I would not, Mariah, I would not put does not exist for the extrema. I mean, I guess that's technically right. You know, I wouldn't mark you off. So I would say put none or does not exist. I'm okay with either one. Again, the 0 from the horizontal asymptote comes that the power on the top, I'm just answering some questions here, folks. The power on the top, okay? What's the power of x on the top of this, okay? The power of x here is 1 x to the 0 power. So we have x to the 0 power on top and x squared if I multiply this out on the bottom. So which one's bigger? This one's bigger. So if the bottom is bigger, okay, bigger than the top, then your horizontal asymptote is y equals 0. That's just the rule, okay? Just got to know that's the rule. Okay. Phew, now we're on 19, guys. We're almost done here. And you know what? I'm going to do 20 first and then go back to 19 because 19 gets a little tricky. So let's look at 20. I think 20 is pretty easy. We're looking at limits. So the limit as x approaches 1 from the left. So I'm going to go to x equals 1, which is right here. And I'm just going to go just to the left of it. So right about right here. And then I'm going to approach it. What is the y value that it comes closer to? It looks like it comes closer to 2. So my limit is 2. Now as I approach from the right, I'm going to go Let's use a different color to show you what I'm doing. I'm going to go, here's 1. Okay, so I'm going to go up here, and I'm going to go just to the right. So just about right here. And then I'm going to approach it that way on the curve. And this time it is 3. So my limit as x approaches 1 from the right is 3. So the limit as x approaches 1, this means from both the left and the right. Are they equal? If they are not equal, which they are not, the limit does not exist. So let's look at x goes to 4. So we're going to go to 4. All right, so we're going to just start from the left of it. And we're going to approach it. It looks like it approaches 1. From the right of it, it also looks like it approaches 1. So we're going to say both of these are 1, and since they're both 1, this is 1. If we understand how, let me answer that question in a second when I wrap this up. So let me do 19 and then we'll wrap it up, okay? Let's see if I can cut and paste this. Come on, cut. Nope, it's not going to do it. Okay. So let's graph this. I'm going to zoom in a bit. The limit as x approaches infinity is equal to -2. So this tells me vertical asymptote. It tells me that because as x approaches, oops, wrong, horizontal asymptote. Because as x approaches infinity, it's going to be -2, and that is the end behavior. All right, so I don't know yet if it's going to approach it from this side or this side, but I know it's going to approach it. I do know that this function is odd, so if it approaches -2 this way, it's going to approach +2 this way. All right, we should first graph the points. So here we got our points. So we're going to go to -3, 2, 3, and that's going to be a point right there. 0 is going to be a point right there. And 1, 2, 3 is going to be a point right there. It says here that the limit as x approaches -3 from the left is going to be +infinity. So that tells me vertical asymptote. Because as I approach -3, oops, from the right, I'm going to approach +infinity. So it's going to look like this, like that. Well, so if it looks like that there, it's got to look like it's going up this way. Then I've got to have one on this side too. That's going down this way because it's odd. All right, there is a relative maximum at x equals 4. This one's a little tricky. A relative max at x equals 4. So here's x equals 4. Somewhere in here I got to have a max. But yet I have to go towards that asymptote. So the best way to draw that is to maybe come up here, then go down, back down towards the asymptote. So we're going to have to do the same thing here. So I'm going to go down here, then go back towards the asymptote. All right, and that is our picture. Well, let's draw everything black here. So we need the points here black. Okay, so there's our picture. That would be our function. Okay, so that is pretty much everything. I'll go and answer some general questions now, just about the test and anything else that you have here. What I'll do now is I'll take this work that I have here, I'll turn it into a PDF, and then I'll post it on Classroom as soon as I get a chance here after I'm done. All right, so how do you decide which one to approach for A and B? Are you talking about, I assume you're talking about 20. It says approach. It says approach negative. It says 1. So as x goes closer to 1, what does y get closer to? Y gets closer to 2. The workbook is due on Thursday, not tomorrow, because tomorrow is only half of the test. So the workbook is due on Thursday. If you understand, this is Brianna's question, was if we understand how to do everything on the study guide, will we be able to do the test? If you are able to do everything from the study guide, then you should be pretty good for the test. The test isn't too much different from the study guide, especially for the free response. The free response is, I mean, I don't think I can get too much different than what I have on the study guide, really. So I think you're pretty prepared for the free response. The multiple choice is, you know, it is what it is. I hate that term, but it is what it is. There's some problems that you know that don't look exactly like the ones in the multiple choice, and there are a couple of problems that do look exactly the ones that like the multiple choice. The multiple choice is really, you know, how well did you understand the vocabulary and the concepts and the little things in this unit. So I mean, it's hard to say with the multiple choice. Let's see what other questions you guys have here. How much is the test going to affect our grade? Well, this unit is, I believe, 20% of your grade. Oh, that's not what I wanted. I can check real quick. So let me log into Infinite Campus and see what I have down as your percentage for this. Just takes me a second here. So Unit 2 is worth 25% of your grade. So this is probably, I think, without a doubt, I think that's pretty non-conclusive, right? This is going to be this. I'm not going to say this is going to be the single most weighted exam, but it is, other than the final. So this is the exam that's going to be worth the most in this whole semester. Unit 2 was the biggest unit, and it's by far the most important unit of all of the units that we do in this semester. This is the one that's the key for calculus, and really opening up a lot of the really important topics that are going to be important for you to know. So yeah, I mean, it's going to be worth a lot. So 25% of your grade comes from this unit, and I think I mentioned that at the beginning of the unit. So you know, hopefully you stayed on track, and you tried to get as much done. And I know that I think we kind of sped through some of the things. So I'll take that into consideration when I'm grading your workbook. What are the 4 topics that are going to be most focused on in the multiple choice test? So Brianna really wants to get some insight on this test. Okay. Give me so are you guys saying same as, who are you agreeing with when you say same? Are you agreeing with Brianna or Vinay? So on 3, the x in the brackets is just another way to write the greatest integer function. Yes, that is correct. Let me check for you real quick, and I can tell you exactly. let's see. So here's the thing. So since you came to my live stream, if you watch this live stream, you're going to get a little bit more detail on the multiple choice. So here's your detail on the multiple choice, since Brianna really wanted to know. Okay. 25% of the grade can bring it down real quick if you get a 0. If you know nothing and you leave the entire thing blank, then yeah, it's going to kill your grade. But you really shouldn't be too nervous, because if you go into the test thinking that you're going to fail, then you're likely going to fail. But you're not. From the work that I've seen that you're doing, from the stuff that I know that you know, you're going to be better off than you think you are. If you haven't done what you needed to do, you haven't watched any of the videos, you haven't stayed on task, you haven't done what you basically didn't do anything, then yeah, you're not going to know how to do anything. How are you going to do anything if you didn't do it? How are you going to know how to do anything if you didn't do anything? And that goes with any type of class. If somebody falls asleep in a lecture style class and then doesn't do any of the homework, they're not gonna pass. They're gonna fail. So it really doesn't matter what the structure of the class is. It's really how much effort you put in, and then how much you do some things like this. When these things like these live streams, things like this are offered, how much do you take advantage of that? How many problems you do on the side, and how much you take advantage of what you need to do. Because you're going to find out that it's going to be easier than you think. You might be kind of freaking out right now, but really just take a breath, because from what I've seen, you guys are pretty prepared. I wouldn't throw something at you and then know that you're really not prepared for it. So what I've seen so far, you guys are pretty prepared. Just don't get it in your head that you're automatically going to fail, because every time you think that, of course you're going to fail. You guys are in this class for a reason. You're really good students. If you feel like you haven't put in the effort that you think you could have, then you're probably right. So if you feel like you've done everything you can and you've worked really, really hard, then you're likely going to do well. That's just the reality, because there is a connection between how hard you work and how well you do. Yeah, I mean, just being here for this last hour is going to help your grade. Doing your work, discussing things in class is going to help your grade. I think that you guys are stressing out too much. All right, you've come, you've listened to what I've said. You're probably going to go back and look at some of these things. You're going to prepare yourself, and by doing that, you're going to be ready. But don't come in thinking I can't do any of this, because once you think that, you can't. All right, so that's enough of my motivation. Let me tell you what's going to be on that multiple choice, because you came, you asked, so I'm going to give it to you. So listen carefully. I'm not going to write this down. You just that's heck of true, Cam. Yep. So you got it. Okay. But everyone that I see on here right now, you've taken the time to this is what this is not supposed to be showing that. Sorry about that. I think you guys are just looking at me, right? Like all you can see is me. Is that true? All you can see is me. So listen, you've taken an hour, it's already been an hour and 10 minutes out of your evening, and I've taken an hour and 10 minutes out of my evening to help you get ready for this test. And you've prepared yourself for the last 3-4 weeks, 5 weeks for this exam. What I ask of you is do the very best that you can. If you think, and once again, if you feel that you've done everything possible that you could do, and that you go into the test tomorrow going, now I did my best. I reviewed the best I could, the best I know I could, and I did the best I could. That's all I'm asking you to do. You know, if you come in, if you've spent only half the time, you've only watched a couple of videos, you never came in for tutoring, and I saw you at lunch, you never asked any questions, you didn't work with your group, you only did half the work, you weren't in class a whole lot, and then you go into the test, you go, well, I don't really want to do this one, I don't know how to do the half of this, I don't really know. I mean, you know what you know, and if you didn't try your best, I mean, I can't help you with that. But I can spend an hour and a half of my time after school in the middle, at night, and do my best to get you there. Okay, so sorry about, that's I guess my motivational speech. Let me talk about the details of the test. So here it is. I'm not gonna say anything else on that. Here it is. Here's what you want to know. Oh yeah, by the way, I did not carve the pumpkins yet. I'm going to end up carving them on Saturday morning because I didn't have time today. We went to gymnastics and then I came back and did this. There is no partial credit on multiple choice. Sorry, Vinay, you got to get it right or wrong. I can't. You're here. Why don't we stop and let me tell you what's on there, okay? So first, you're going to have problems about odd or even. Know how to determine if a 12 basic function is odd or even. Know how to determine it by plugging in negative x. Second, you will have to decompose a function. Be very careful because if part of anything is in a power, that is where the x goes. I think you guys can figure out what I'm talking about. You'll have a basic horizontal asymptote. Remember the rules because it might not be as simple as me giving you the powers equal. Remember what happens if the power in the denominator is bigger than the numerator. Remember if it's big over little, little over big, if they're equal. You need to know those. Again, remember the definition of odd and even. Not just that it's symmetric about the y-axis, just symmetric about the origin, but remember that f of negative x equals f of x is even, f of negative x equals negative f of x is odd. Because if I give it to you in that format, just like I did in the study guide where I said, which one of these is symmetric about the origin, that was really a hidden way of saying which is odd. I might give it to you like saying which of the following is f of negative x equal to f of x. Then you need to find which is even. So you need to be very careful about that and know those rules. Second, know how to find the inverse function, right? It's not that hard. Switch the x and the y, solve for x. Be able to do that. That's going to be on the multiple choice. There will be a piecewise function on the multiple choice, and the piecewise function will basically be just pieces of a parent graphs. So that's probably the trickiest problem on the multiple choice. You need to be able to take the parent functions and translate them and kind of see what they're going to be on a graph. So I'm going to give you a graph and you have to pick the right piecewise function. And that one I can't really give you an example of. I just really think that if you can just take what you know of piecewise functions and then take what you know of translations and just know those two, I think you'll be fine with that. Next, remember the step-by-step graphing. There'll be a couple of problems where I just give you the function, like let's say I say what's the graph of f of x equals 1 over x squared. You need to know what that looks like based on the taking the basic functions and doing the step-by-step graphing to them. And then there'll be some true and false questions, some just straight up true and false, like what is the range of a polynomial function? Is the sine function all real numbers for its domain? Just simple statements about different things that we learned in class. Make sure you know the difference between a vertical line test and a horizontal line test. What does the horizontal line test find? How do you use the horizontal line test when you're looking for if a function has an inverse? So, these are important questions these are important concepts to know. So this is very basic concept questions. They're not going to be like, really, really hard, like really long questions. They're basic concept questions. I'm getting a lot of questions here on the classroom, but let me finish with this and then I'll answer some of those. I think there's some really, in my opinion, some really quick and easy ones. Like I might give you a function and I'll give you the graph and I'll say which of the intervals are concave up or which ones are concave down or what's increasing, what's decreasing, and I'll give you some options. So all you got to do is, look at the graph and see which one's which. And then, of course, I think the points that you get, the easy points you get, are the one with the table, just like in the study guide, where I give you the table of values, and you just got to plug them into the thing and find the answers. Okay, so I think that one's a pretty simple one, and that's about it. There's all over the place with those. I think that's about it that I can ask you on that. So it's kind of I went through a lot of stuff, but I basically gave you a play-by-play of the multiple choice in terms of the concepts. Okay, so wow, there's a lot of stuff going on in the classroom right now. Let's take a look what's going on. I don't have it open. Oh, they're all thank yous. You're welcome, guys. Yes, I was supposed to carve pumpkins. Really what happened was we had gymnastics tonight, and then we went to dinner. Red Lobster, really good. I love Red Lobster. And then I decided, we'll carve pumpkins later. We've got a few days left, so we'll go and carve pumpkins on Saturday. That way they're fresh and they don't get like smashed up and yucky outside. So it's all good. Thank you. You're welcome. So if there are two powers that are odd, does that mean the function is odd? In a polynomial, yes. The multiple choice is tomorrow, then the short answer is Thursday. What was the definitions of odd and even again? The whole FX thing. Vinay, you can, this video will be on YouTube, and you can go and replay what I said. So if your video went mute, Brianna, just like I said again, go back and watch the video again. It's good. Once I stop this and I stop doing the live stream, it's going to go right into YouTube. And what I'll do is, as soon as the YouTube gets placed up there, I'll take that YouTube and I'll place it on Classroom and on. Well, it's kind of late for Remind, so I'm going to only put it on Classroom. Okay. It is 9:19, and Marvel Agents of S.H.I.E.L.D. is asking me to go watch it. So I'm going to go do that. Oh, I got a couple more questions. Hold on. When you do odd, is the line, is it like y equals x or y? Yeah, y equals x is an odd function. There will be test corrections. But the test corrections, and this is a question from Asia, will there be test corrections? This unit is so important. I feel that the topics in this unit are so important for your later success that there will be test corrections, but the test corrections will be an assignment. They won't help your grade in your test at all. But there may be an opportunity for a retake. Again, that means I have to go and make another test and make a retake, and that takes time. So we'll see what the grades look like. But for now, yes, there will be test corrections, but they won't increase your grade at all. They'll just be an assignment for the next unit. this is very long. You can hear my clock in the background? Oh, I guess you can. It's right there. Okay, well, it's getting late for me. It's past my, no, it's not past my bedtime. I do stay up later than this. But like I said, I need to go watch. I missed the Warriors game. I'm not saying that it's a bad thing because I missed the Warriors game because they're only my second favorite team, but I do like watching Steph Curry play. So I'm going to go and watch Agents of S.H.I.E.L.D. now, and I will see you guys tomorrow. If you want, you can come by early in the morning, but like I said, I know that a lot of stat students are coming by at 7, and I'll be there hopefully around 7 a.m. And you can always come in Thursday because Thursday is tutoring. All right, so I'll catch you guys later. Thank you for stopping by and going to being here for this live stream. Hopefully it helped you. And if you're not in my class and you watch this live stream, thank you for staying for over an hour and listening to some math work. And hopefully it helped you in your class. Okay, so thank you very much and good night.